Hello, I am the developer of the Planet Simulator. In this video, I will guide you on how to use it. First, let's take a general look at what this asset pack offers. In the Blueprints folder, you will see the Planet, Planet Simulator, and Space Blueprints. The Planet Blueprint allows you to create a planet, the Planet Simulator Blueprint allows you to simulate the created planet, and the Space Blueprint allows you to prepare a space background. The Planet Name Widget Blueprint is the blueprint necessary for displaying the name of the simulated planet above it. The Player folder contains the widget, player, and game mode, prepared for demonstration purposes. If you are building an extremely large map, it allows you to move around quickly, slow down automatically when you approach a planet, and focus on the selected planet, making it easier to use this asset pack. The Spline FX is a Niagara system created to draw the orbits of the planets. In the Levels folder, there are 3 ready-made levels, including the solar system. The spline material is the material used by the Spline FX I just mentioned. The stroke material is the material of the planet placeholder. It allows you to make the axis, equator, and stroke of the planet you are simulating visible. The Material Functions folder contains material functions created to combine 8K textures to prepare 16K and 32K materials. Space materials have been created with the help of these functions. In the Planet folder, you will see 2 master materials, Master Planet Material and Master Ring Material. All the material instances you see here have been created with these master materials. You can right-click on the master material and create a new instance by selecting Create Material Instance and then edit it. Let's take a look at the pre-made Earth material instance. By adjusting the parameters you see here, you can create your own planet material instance. When you examine Mars, you will see that it also has the same parent material, and it was created just by changing these parameters. In the Space folder, there is 1 master material and 2 material instances created from it. One of these is 16K, and the other is 32K. You can adjust the brightness of the stars with the Space Opacity parameter. The Meshes folder contains static meshes used for planet placeholder and space. The Planet Simulator logo is the logo used in the Demonstration Widget Blueprint. In the Planet's 8K folder, there are 8K textures of the planets. In the Space 16K and Space 32K folders, there are space textures divided into 8K pieces. After this initial introduction, we can now start creating something. Let's first create a new empty level. Add a Planet Simulator blueprint to the scene and set its location values to 0. Import Planet allows you to import a planet into the simulator in the scene. Add Child Planets allows you to select other planets that will orbit this planet. Additionally, you can enable or disable options such as Display Name, Display Stroke, Fill inside the stroke, Display Equator, and Display Axis here. Planet Name is the name that will be written on the planet. Let's call this Planet A. Additionally, you can adjust the colors of the name, stroke, equator, and axis. Here you can determine the radius of the planet in centimeters. But if you want this value to be processed in kilometers, you can set the planet scalar value to 10,000. Axial tilt, as the name suggests, allows you to determine the axial tilt of the planet. Local rotation allows you to change the rotation of the imported planet without disturbing the simulation. Since there is no imported planet right now, I will skip this setting. Simulation Start Position determines the starting position of the planet's rotation around its axis. Day Period determines how many seconds it takes for the planet to make a complete rotation around its axis. Barycenter is the point around which 2 or more celestial bodies revolve due to their gravitational pull. If you want the planet to wobble around a specific center, you can check these settings. Barycenter Radius determines the radius between the planet and the center of mass. Barycenter Location determines the position of the center of mass. Barycenter Rotation determines the tilt of the barycenter radius. Barycenter Start Position determines the starting position of the planet's wobble around the center of mass. Barycenter Period determines how many seconds it takes for the wobble to complete one rotation. Let's set this value to 10 seconds and see what happens. As you can see, the planet is wobbling around the center of mass according to the specified settings. Now let's play with the orbit settings a bit. Orbit radius determines the orbit of the planet around a body in centimeters. Orbit rotation, as the name suggests, determines the angle of the orbit path in the galactic plane. You can change its color to avoid confusion with the ecliptic path. Orbit start position determines the starting position of the planet's orbit. Orbit location allows you to manipulate the distance between the center of the object the planet orbits and the center of the orbit. Orbit period determines how many seconds it takes for the planet to complete an orbit around the object. Let's set this value to 20 seconds and see what happens. As you can see, the planet is orbiting around the center of the orbit according to the specified settings. Now let's start from scratch and try to simulate the Sun, Earth, and Moon. Let's name this the Sun and change the color of the stroke. We don't need the equator and axis to be visible. I will enter the radius of the Sun in kilometers reduced to centimeters, otherwise it will be too large. But if you want to attempt to create its actual size, you can multiply it by 10,000 using the planet scaler. We don't need to deal with the other settings here. According to my research, the barycenter of the Sun is 829,200 kilometers from its center, and I will enter this value reduced to centimeters. I will set the barycenter period to 10 seconds for now to check if everything is working correctly. I think this period is the same as Jupiter's complete orbit around the Sun, which is 4,332.3 Earth days. If I am wrong, please mention it in the comments. I will enter this value as 4,332.3 by taking 1 Earth day as 1 second. Since we will consider the Sun fixed at the center, we don't need the orbit settings. Let's now add a planet blueprint to the scene and set it as the Sun. To avoid confusion, let's rename the blueprints. As I mentioned at the beginning, Import Planet attaches the selected planet, actually, this is now a star, to this simulator. Here we go. We no longer need display stroke. Take note of this. The radius value of the imported planet will overwrite the radius value of the planet simulator blueprint. If you notice any mismatch and confusion, click the refresh button at the top. Before continuing, let me copy the post-process settings from a different level here. You can change the game mode to Planet Simulator Demonstration Game Mode to move around more easily. Let's temporarily move the Sun to a different position before adding a new planet simulator. This way, we can work more comfortably in the scene. Now let's try to simulate the Earth. Set the radius values to 6,378.1 for X and Y, and 6,356.8 for Z. Set the axial tilt value to negative 23.44 for X, and set the day period to 1. It looks like we are doing well. Now add a planet blueprint to the scene. Since the planet blueprint is already set as Earth, we don't need to change anything in its values. Now let's import this planet into the Earth simulator. It seems we have a small problem here. The planet appears dark because there is no light in the scene. This is because the master planet material is designed in such a way that the position of the selected light direction object makes the face of the planet visible. If we select this option as the Sun, this problem will be solved. Now let's set the barycenter settings for the Earth. Since the Earth is affected by the Moon's gravity, it wobbles approximately 4,671 kilometers from its center of mass. Let's enter this value reduced to centimeters. Set the barycenter start position to 180. This way, the starting point will be away from the Moon that we will add later. Barycenter period is again equal to the Moon's complete orbit around the Earth, which is an average of 27.3 days. Now let's continue with the orbit settings. You can increase the resolution of the path with the segments option. Set the orbit rotation value to 7.25 for X, and set the orbit period to 10 seconds to make sure everything is working correctly. Alright, everything seems to be fine. We don't need to see the ecliptic path here. Set the orbit period to 365.25. Finally, let's set the orbit radius, which is the distance to the Sun. Let's center the sun again. With the Add Child Planets option, we can attach the Earth to the sun. This way, in case of any movement of the sun, the Earth will also move with it. Now let's try to simulate the moon. Since we will be repeating almost the same things, I will speed up this part. After making all the settings, we can now attach the moon to the Earth. As you can see, while the moon orbits the Earth also orbits the sun. Now let's import a planet blueprint for the moon. And as a finishing touch, let's add a space blueprint to the scene. Besides this tutorial, I suggest you check out the solar system level once you understand how it works. In this video, I've tried to guide you on how to use the Planet Simulator. You can write your questions or suggestions in the comments section. Please consider subscribing, and I'll see you in the next video.